All right. So today we're going to continue. We're going to continue looking at how we can build triangles and whether or not when we build that triangle, will it be exactly the same as everybody else's. So in the previous lesson, we learned that knowing the lengths of the three sides of a triangle, provided that we can make a triangle with those three side lengths. Let's back up and talk about that real quick. So what has to be true about the three sides in order to be able to make a triangle?
The two have to be bigger than one.
Yeah, any two sides have to add up to be more than the third side. And usually what we do is we check the two short sides. If the two short sides add up to be bigger than the long side, we know it's going to work and make a triangle. If that's true, then we know that my triangle is going to be exactly the same as your triangle. It's going to be exactly the same as everybody else's triangle. We also learned that that's not true when we know the measures of the three angles. If I have a triangle that is 80, 10, and 90, it's not going to be exactly the same necessarily as your triangle that has an angle of 80, an angle of 10, and an angle of 90. They can be very different sizes. So today we're going to look at two other possibilities. So if you have not already done so, go into Google Classroom and tap on the link titled CC2 8.3.4 Example 3, Triangle from two given sides and the angle between them. I want you to build a triangle that has the side lengths and angle measure given in each case below. Once you have yours, before you go on to the next one, so you people who like to zoom ahead, don't do it. Once you have yours, check your sketch against someone sitting near you. Is your triangle exactly the same as the other person's? Then draw and label a sketch of your triangle in each case. So for this first one, we want a side of 6, a side of 8, and an angle of 90. Once you've made it, see if you can grab hold of one of the vertices and change something. Or grab hold of one of the sides and see if you can change something. Don't just go, well, mine started off the same as everybody else's. Check to see if yours matches with the people around you. Once you've checked that, then I want you to draw the triangle on your paper, label the side lengths and the angle measures. Once you have that one, move on to the next triangle. I was very specific. Check with the people. Have you checked? You've already checked. Maybe you're leaving someone out. Don't leave people out. That's not nice. And it's not a race, guys, okay? to here, label all the sides and all the angles, all the side lengths, all the angle measures. And answer the question. Yeah, put the angle measures also. Because if the angle measures aren't the same, then your triangle and my triangle aren't exactly the same. All right, so is everyone done with at least A and B on the front? Is anyone not done with those two? Okay, so if you'll look at your A on the front, please. Does yours match up with mine? Maybe not turned the same way, but are all the measures the same? Yeah, and notice what we have. The sides that we know these two sides to start with and the angle that's in between them. It has to be the angle that's in between them. Sometimes books will call that the included angle. It's not super important that you know that word now, but you'll need to know it when you get to geometry. It's called the included angle because it's in between those two. If you have those two sides, you have this angle. It's called the included angle. So, is knowing the lengths of two sides and the measure of the angle between them enough to know that the triangles will be the same? Yes or no? Yes. In geometry, we sometimes abbreviate that SAS for side, then the angle between them, and the other side. Right? The reason we put the A in between the two S's is because the angle is in between the two sides. All right, try the one on the back then if you haven't already started on that. God bless you. And again, once you have one, check to make sure the people around you have exactly the same thing that you do or don't have exactly the same thing that you do. Bless you.
Did you get everything, sir? Yeah. So like something like this. Yeah. Is it a right angle? Bro, why'd you draw squares in it?
No, that's meant to be a circle. That's meant to be a flexor. Is that better?
Bro, why does it also look like a right angle? No, just no the angles. Like the lines make it look like a right angle because of how you put those together.
Bro did not say that. Bro did not say that. What do you mean? Bro, yeah.
Bro, kids, taking pictures of them.
All right, gentlemen, waiting on some of you who are talking to finish so we can go on. All right, does everyone have at least A and B for this? All right, so look at yours on A. Does it match mine? Yeah, everybody's matches. So, is knowing the measures of two angles and the length of the side between them enough to know that the triangles will be the same? Yes. And again, when you get to geometry, we call that angle, side, angle, because the side is in between the two angles. If you look back up here at this picture, I've got an angle, and then a side, and then an angle, all right here in a row. So that's why it's called angle, side, angle. I do want to show you one thing before we go on. What if it's not the in-between angle? Or what if it's not the side in between the two angles? Well, actually, let's do that first. What if you had instead, I gave you this angle was 65, this angle was 80, and this side was 7? Would it still work out?
No.
Why not?
Because you don't know the distance between the first two angles.
Well, if this angle is 65 and this angle is 80, how much is this angle going to be? 35. So now I have this angle, the side between them, and this angle. So it does work. It turns out, and you'll learn more about this later, it's not important that you remember it for now, that angle side does work to prove triangles congruent, to prove that they're exactly the same size and the same shape. But for the side angle side one, it doesn't work if they're not in that order. Let me show you what I'm talking about here. Oh yeah, I need to go here and open it. Why didn't it open it? All right, so everybody watch this one for just a second. So right now, I've got a side of 4.7, a side of 6.3, and an angle of 45. And the angle is not in between the two sides, and it's working just fine. And I can, oh, wait a minute. I now have two completely different triangles that have those same things. So what happens is this angle is 45 still. This side is still 4.7. This side is 3.5, and so is this one over here. What happens is the final side can swing in towards the original angle, or it can swing out away from the original angle, making two very different looking triangles. The whole big triangle is one, and this one over here on the other is the other one. It makes two completely different triangles, which is why side-side angle doesn't always work. Yes, sir?
Are we gonna do that on a test?
No.
Oh, thank God.
I'm just previewing a little bit of geometry for you.
Geometry?
All right.